Welcome, everyone. This is the fourth Friday in February, and so this is the fourth session in our series of workshops, where the goal has been to give participants direct experiences with student activities for learning statistical concepts. So my name's Alan Rossman. I teach here at Cal Poly in the statistics department, Cal Poly in San Luis Obispo, California. I'm very pleased today to introduce my Cal Poly colleague, Soma Roy, will be leading today's session on the topic of introducing students to simple linear regression. Soma is a professor of statistics here at Cal Poly in San Luis Obispo. She's a previous editor of the Journal of Statistics and Data Science Education. She's also a recipient of Cal Poly's Distinguished Teaching Award, among lots of other accomplishments. But I'll stop there and turn it over to Soma after I again say thank you all for being here. And thanks especially to Soma for leading us through what she's about to. So take it away, Soma, please.
Thank you, Alan, and hello, everybody. Thank you for being here. Just a quick reminder that next week at a different time, it's at from 5 to 6 p.m. Eastern Time, Beth Chance will be leading a session on the Monty Hall problem. And I'll remind you again at the end of the day today, or end of the session today. So today's topic, like Alan said, we're going to talk about simple linear regression, and the motivating question or context is going to be predicting height from foot length. As Alan said, I'm at Cal Poly in San Luis Obispo, California. So quick overview of what I will be talking to you about today. I'll tell you a little bit about my typical class structure for my intro stats courses, so how they're set up, etc. The order of topics and concepts, how the exploration, so we'll kind of go over the exploration or the lab or activity, and I'll be using these words interchangeably. So if I say activity, lab, exploration, essentially I'm talking about the same thing, about this research guided discovery process that the students are going through via or to get to the answer for a research question. I'll tell you a little bit about in the order of topics concepts, where this activity is situated, what they have done in the prior class period or class session, what they've done right before coming to class, hopefully, and we'll try out the lab together. I'm hoping you will take on the role of a student in my class and kind of try these things out with me. We do have a time constraint, so we'll have a somewhat abbreviated version of it. But for the most part, I'm hoping you'll kind of get a sense for what my students experience via this lab. I'll also give you a little bit of information about what the students are expected to do after class, and then we'll do a wrap up of the key takeaways. So typical class structure, what we have, or what my classes here are set up as, we are on a quarter system still, so we meet for 10 weeks, and each week we meet for about 4 class periods. Each class period is about 50 minutes long. I have this alternating pattern of a lecture lab pattern. So like on the lecture days, what I do is I set the stage for what they are going to do in the following day's class session, which is set up as a lab or an activity period. And so on lecture days, we kind of talk about what they are going to see the next day, but also tie up loose ends from the previous day. So if there are any big concepts that need to be reviewed or reinforced, that's also done on the lecture day. And on the lab days, the students work on a guided exploration. Typically, I kind of introduce the topic. I kind of remind them what they're going to be seeing, what they have already seen, the learning goals for that day. And at the end, we do like a 5 to 10 minute wrap up. So there is closure on what they should have seen, what they should have, the big ideas of that particular lab. And in between, so the rest of the time, what the students are expected to be doing is working in hopefully pairs on the lab handout or the guided exploration. And we either do it in a computer lab if one is available, or they just bring their own machines and we're in a regular classroom. And most of these activities that I have, because they mostly use applets, and all of the applets that are available on the Rossman Chance applets, they're all kind of, they work on iPads and iPhones as well. So they don't have to bring a laptop. They can just work on their smartphones or iPads if they like. All right. So while the students are working on these labs or handouts or these explorations, I walk around, answer questions, kind of interact with them one-on-one, ask them questions at different time periods. And if I have a TA available that quarter, I also have a TA or a teaching assistant, then both the TA and I will walk around and interact with the students one-on-one, asking them questions, checking in with them, and making sure that they are staying on task and also getting the ideas correct. Before and after each class period, students do complete a concept check quiz. So that's a quick and easy way for me to make sure that they're prepared for the class period that they're going into and that they have gotten the big ideas from that particular class period if they're doing afterwards. As Alana is pointing out, yes, we have our classes are about 35 students, are capped at 35 students. These concept check quizzes are very low stakes. I give about one every class for every class session. So because it's a 10-week class, we meet about 40 times. So there's about 36 quizzes I give, and I drop the 4 lowest ones. These are auto-graded. These are on Canvas. And I can kind of see a quick snapshot before class or after class as to how students are doing on each of these concept check quizzes. And I'll give you an example of that. The order of topics. So I think Jill mentioned last week a little bit about the order of topics, and I'll kind of give you a quick idea of what happens. So we have in this ISI curriculum, we do what we call the spiral approach. So we kind of do descriptive statistics, tests of significance, and confidence intervals in a spiral way where we kind of use a research question based on a particular data type and go through all of these concepts, the descriptives and the inference for each topic. And for the inference, we use both simulation-based inference as well as theory-based inference. So we typically start with one proportion, move on to one mean, then two proportions, two means, comparing of two means. And comparing two means is something you saw in Jill's session last week. And then the previous session, you saw one proportion. So we'd kind of do something like the marine example for one proportion, and then the dung beetles for two means. And then we'd go into paired data, more than two means, or ANOVA, R by K tables, or chi-square tests, and then wrap up with the association between two quantitative variables or regression. This is where my activity would be situated for my class, but I'll kind of give you a reason or reasons for why you don't have to wait till the end of that class session, or sorry, the quarter of the term. You can kind of do it right at the beginning as well. All right. Examples of tactile simulations they have seen at this point. So because it's coming at the end of my order of topics or concepts, at this point, by this time of the quarter, this is where we're wrapping up almost, they have seen coin tossing to simulate 50-50 processes. They have seen spinners, die rolling, card shuffling for non-50-50 processes and matching problems. They have seen card shuffling to simulate random assignment, to simulate what the difference in means could be or the difference in proportions could be for two groups, more than two groups, and so on. So they have some idea of how to run a tactile simulation and also how you use applets for simulations. What has happened in the previous class period? So I want to make sure that, and thank you for asking questions on the chat. And if you have questions, please make sure that you interrupt me and ask questions on the chat or just unmute and ask me. So now we're going to get into this point where you kind of know where this activity is situated. And we're going to start talking about the activity, but let's quickly take kind of a step back and think about, before they start this activity, what it is that I have prepared them with right in the previous class session. So in the previous class session, they have looked at scatter plots for two quantitative variables. They have talked about how to describe associations when you're looking at scatter plots, so describing the direction, form, strength of association, identifying outliers. They've also talked about how to quantify the direction and strength of a linear association with the correlation coefficient. So they've seen R, they've seen how R varies between -1 and +1, what it means to have, what absolute values, high values of R mean, and so on. They've also kind of talked about how if you think the association is linear, you can use a line of best fit using a least squares regression line, and how that gets decided on that, there's only one line of best fit. So for an example, one data set that students use is how the prices of used Hondas vary with how many miles the car has been driven. So, they've looked at a scatter plot using the applet, miles on the x-axis being used to predict the price on the y-axis or the vertical axis. They've seen what a correlation coefficient. So as the number of miles are increasing, the price is estimated to go down. So there's a negative, strong, fairly linear correlation that we're seeing. And they have looked at a regression line. So this is kind of where they have stopped. They have come up with a regression line. Here's a predicted price. There's in their math classes, they've seen an intercept, they've seen a slope. And we are now in this next class period going to talk about unpacking that equation. All right. All right. So they do that the previous class session. Before they come to class for this lab or this exploration, they are going to complete a concept check quiz. So the objective, again, is to make sure they've seen another instance, not just the used Honda prices, but also another context, so they can transfer that knowledge in the context of other two quantitative variable associations. Again, it's low stakes, quick, auto-graded. For example, here's a question. This is a screenshot of what my Canvas quiz would look like. And it's just a matching question. It's asking, okay, well, data were collected on the size of houses and price of houses for a sample of houses in Rio Grande, sold in 2006. Match the statistical term to the contextual description. So what's the observational unit? What type of study is it? Is it, what's the research question? And I like asking that research question as well as the two variables separately, because sometimes students tend to get confused between what is a research question versus what is a response variable versus explanatory variable. They'll also see, another example here on that same concept check. They see this example where each unit is actually a country, and you're looking at how the average number of births per woman is related to the average life expectancy of women. And here is a negative association. So, you're identifying the observational unit, which of the following is the best description of the scatter plot. What can you say based on the fact that this is an observational study? What should you not be saying? And then estimating what that correlation coefficient might be without actually calculating it. Which of these values look like a reasonable value? It should be negative, it should be somewhat close to 1, and so on. All right. So now let's get to our exploration. So the exploration that we're looking at is predicting height from foot length. And so the background that I kind of like to kind of give them a motivation for why anyone would care about this research question. So the background that we talk about is more like a CSI, a crime scene investigation, basically. So, let's say that a footprint has been found at the scene of a crime. Can we use that footprint to figure out or to predict what the height of the perpetrator or the criminal might be? So, lots of times investigators find different clues on a crime scene. How do they use that information to figure out who the perpetrator might be, and so on? So this is the background we set up, and we talk about that. And now we're going to get into the activity. So they've come to class. I have told them in like a 30-second intro, we're going to pretend we're looking where we found a footprint. How are we going to use that information to predict the height of the criminal? And so I invite you to click on that link that says activity, and we're going to go into the activity, which is on a Google Doc. And you'll notice that you can actually just, you're probably all familiar with this already, but you can kind of go in there and you can make copies of it. So typically how this activity is set up is I list what learning goals that is going to achieve. So I kind of remind them, there are some learning goals we will be revisiting. So some things that you have seen before, and here are some new ones for today. And so those are the goals that we are seeing today. And here is a reminder of the background. And we're going to investigate this question, but we need data to investigate that question. How are we going to figure out what this association between footprint and height is? Well, we need data to explore that. And so for that, we have data from a sample of 20 statistics students. So this particular context is a great example of where we can actually collect data from our students. So, you could ask your students to report their height and foot length, just like these students did, and their heights were measured in inches, their foot lengths were measured in centimeters. And because now the students have provided the data themselves, they can begin to make some closer connections between how the data were collected and what type of study it is, who the observational unit is, what the variables are, and so on. And they can kind of see themselves in the data to make those connections. So let's go ahead and start warm up a little bit. So we have this data on a sample of 20 statistics students. We have their height in inches and foot length in centimeters. Do you think, and please use oh, that's a good question. So do the students measure their foot length with shoes on or without? I actually asked them to measure their foot length without the shoes on, and then from the tip of their big toe to behind their heel, basically. All right, so if you want to jump in on the chat and tell me, do you think this is so we're now pretending you're students and you're kind of going to answer these questions. And typically you would be working as a student with another partner in class, and I wouldn't be interrupting you so much or asking you to answer these questions on the chat. But because we're doing a workshop session, I'm going to ask you to put on the chat, do you think this is an observational study or a randomized experiment? All right, I'm seeing lots of observational. Why do we care? And how do we know? How do we know that it's an observational study? And if it's faster for you to, okay, we aren't controlling, no manipulation of variables, no randomized treatment. Yeah, so I like to get very specific and tell them we did not randomly assign the explanatory variable or manipulate the explanatory variable, which then brings them to, well, what is the explanatory variable? But before I ask you that, why do we care? Why is it important for us to note what type of study it is? Ah, you got it. So I'm seeing association versus causation determines the scope of conclusions, or can I conclude cause and effect? So that's a great point. So I do want to make sure that I remind them what type of study it is, because that's going to help them later on when they're thinking about, can I conclude cause and effect from this? All right. Let's keep going then. Great work so far. What is the observational unit? A student, all right. All right, we could say each person's foot as well. That's also going to give you the foot length. But why might I prefer student over foot? So these are the kinds of discussions I would be having, because we're also recording height. Exactly, right? So these are some answers that you want to kind of think about. So you might want to actually sprinkle in some answers that that raise questions like, why would one answer be more preferable than another? All right. Why do I care who the observational unit is? I'll get to your question in a second. But why do I care what the observational unit is? Something to do with the Yeah, because it helps us see what each point in the scatter plot represents. Because at the end of the day, I do need to make some sort of generalization, right? Like, who am I talking about here? Am I talking about, I don't know, cats? Am I talking about people? Am I talking about tables? What am I talking about here? So just to kind of make sure that I understand the context, I'm talking about, students. So it represents a particular population. What population is the sample going to represent? And that's why it's important to kind of make a note of what the observational unit is. All right. Okay. Well, we have our observational study and observational unit down. Let's talk about explanatory. So what's our explanatory variable, and is it categorical or quantitative? We are seeing foot lengths and quantitative. All right, so we want our explanatory variable to be foot length because remember we found a footprint and we want the footprint to tell us about height. So that direction is the reason why we would choose foot length over height as our explanatory variable. So we are trying to see if we can predict height from foot length. So we want foot length to explain height, which is why we choose foot length at explanatory, and it's quantitative, it's measured in centimeters, which means then whatever is left over, which is height, is our response, and that's also quantitative. So a while ago, I think Tana was asking a question, do you answer these questions in front of a whole class or per group of students? That's a good question. So it depends. Sometimes and because during the lab, they're basically working kind of in smaller groups and basically in pairs. I'll walk around and have these conversations one-on-one. But if I start seeing that there are some like questions that are arising more often among all groups or many groups, then I'll kind of stop them and say, hey, let's just regroup for a minute here, chat about this before you go on, because it seems like it's coming up a whole lot. So kind of go back and forth between just having a one-on-one discussion or pulling the whole class together if I see if it's becoming something that the whole class should participate in. All right. Thank you, folks. Keep the questions coming. All right, so we're going to now hop on to Beth's applet in a second here. So right now what we've done, we figured out what type of study it is, what the observational unit is, what the two variables are, and then now we're going to start actually exploring the data. So we're going to hop on to our correlation regression applet, where the data set actually appear pre-entered. And there are several other data sets that you can kind of look at. For now, we're going to just stick with the foot length height data, and I'll let you know that you can actually paste in your own data as well. So, this doesn't have to be the preset data set. If you collect data on your students, you can copy paste that from an Excel file, text file, whatever, into this this applet sample data window. All right. And you're seeing the scatter plot. So I'm going to go back and forth between the applet and the questions. But this is the scatter plot that it has generated. So you can see what the scatter plot looks like. And if you look at the scatter plot, what is it showing you? And question number 2 is asking you to describe the association between the variables as revealed. So we're going to I'm going to pick up the pace on the next few questions so we get to the meatier part more quickly. So they should be able to tell us that, you're seeing a positive, moderately strong linear association. And then in the correlation regression applet, you can see something called the correlation coefficient box. So you can actually check on the correlation coefficient box, and it tells you, kind of quantifies that strength of association and the positive association for you. So it's saying that it's a moderately strong positive association between height and foot length. It has chosen height and foot length and in the correct places. But you could, if you wanted to flip these on the two axes, you can actually click on that button to flip them. But we're going to stay with this order because that makes more sense for us because we're trying to predict height from foot length. All right. Would you say a straight line could summarize a relationship? Yeah, looks like it's pretty linear. Looks like the association's pretty linear. So we can say that a straight line is a good summary of that association between height and foot length. And then there is a reminder for them as to how this line, this straight line or this best fit line is going to be chosen, what that looks like. So here's your predicted response is equal to some intercept plus some slope times the explanatory. So as a reminder for them, how this line was chosen, what the line's formula looks like or form looks like. And then they can use that applet again to obtain that or determine this regression line. So notice again that the applet is kind of nice and that it actually gives that height for them with the hat on it. So it's telling you height hat. So it's putting it in context is equal to 38.3 plus 1.03 times the foot length. So it's giving you that equation, which the student, because they're working together with their partners, they're going to presumably write it in for part A. And that's what their equation is. This should be a quick one. So part B, 5B, so we all know. Will everybody in the class get the same equation? Yeah. Why yes for this particular equation? They should. They might get it wrong, but the applet actually will always, depending on if they put all the data in there correctly, they should get the same equation because that is the line of best fit. And the same data, same method should give them the same equation. If they don't, that's a good check, for the instructor to kind of say, oh, okay, well, you should have gotten the same equation. Why didn't you? And this is a place for us to step in and say, let's make sure you're doing things correctly. Is the slope positive or negative? It does look like a positive slope. So right there. And then that's another way to kind of reinforce the idea that the positive slope has the same sign as the positive correlation. So if that is different for you, then let's check what happened. If you got it, maybe you typed in something wrong or you didn't choose something went on with your data set. And how the positive or negative slope tells us about the positive or negative association. They can then go on to kind of interpret what the slope means. So they can say, okay, well, one way to interpret the slope is just have them see how the response variable changes by plugging in numbers. So this is kind of how I do it. I ask them, okay, well, let's say you use that equation to predict the height of someone whose foot length is 28 centimeters. So what you're going to do is you're going to simply plug in the value 28 where you see height. Foot length. So you're going to plug in 28 here, and it's going to give you a predicted height. And you're going to do the same thing for part B of that question, but now you're going to plug in 29. And so I'm going to ask you, what do you think is going to be the difference between the answers in A and B? How much will your predictions differ by? Whatever the slope is, or the 1.03 centimeters, that's right? So they are hopefully seeing that number looks familiar. So I see a question here. Do you at some point talk about the difference between slope and R? Yes, we do. So correlation coefficient, they've kind of seen in the previous class period that's a measure of kind of just the association. And now we're going to get into a measure of the strength and direction of the linear association, and the slope will have a different interpretation. So basically, their interpretations are different, and that's how we're kind of addressing the difference between the slope and the correlation coefficient. So once they've kind of answered part see, and they are seeing that the answers in A and B differ by 1.03 or whatever the value of the slope is, they kind of know that that's what, that number should be the slope. And so one way to interpret the slope is to tell me how much the predicted height will differ by for every 1 unit increase in foot length. So that's how students in my class are interpreting the slope, or they're kind of discovering, self-discovering, or as I like to call it, it's a guided discovery. So by asking these questions, we're helping them discover these different concepts or ideas or methods. So here is a reminder of what the slope coefficient can be interpreted as. And then they can fill in the blanks here, saying the slope of the regression line predicting height based on foot length is 1.03 centimeter, 1.03, meaning that for every additional 1 centimeter increase in foot length, the predicted height increases by 1.03 inches. Any questions so far? Or asking questions, so keep that going. All right. So let's see. We have then, because they just talked about that equation, the equation has a slope and it also has an intercept. So they've talked about, now we've interpreted what the slope means. We can interpret what the intercept means as well. So we can do that via this fancy technique of plugging in again. And we asked them, okay, or I asked them, in this least squares regression line, go ahead and predict the height of someone who has a foot length of 0 centimeters. And then what do you think that answer is going to be if they plug in 0 centimeters into that equation? You can put it in the chat or just unmute and holler. 38.3 inches sounds good. And where is that number coming from? It's coming from the y-intercept, right? So essentially the y-intercept is what the value of this predicted response would be if x was set equal to 0. So in the context, what does it mean? Is it meaningful? Does it make any sense to say that a person who has a foot length of 0 centimeters is 38 inches? No. So we have a discussion about that as well, like how the y-intercept doesn't have to always make sense. Sometimes it's there to just make that line, to be able to draw that line, to give it a starting point. And also how plugging in 0 might be an example of what we call extrapolation. So extrapolation, where you're going beyond the scope of the observed data to make predictions via that regression equation, the least squares regression equation. So yes, sometimes the intercept might make sense if 0 is within the scope of the observed data, but if it's outside, it will give you misleading predictions. All right. So most of these questions, so then they can talk about part 8 talks about use the equation of the line of best fit, because remember we found a footprint of 32 centimeters. Okay, so if you found a footprint that's 32 centimeters, what would the line predict the height of that person to be? And so kind of getting to this idea of, you're not going to make perfect predictions, but because it's the line of best fit and least squares regression line, it's going to kind of, you're going to overestimate sometimes and underestimate sometimes. And you kind of need to think about the fact that you might be off a little bit from what the observed value is. So far what they've, yes, Jennifer, go for it. Sorry, I thought I saw a raised hand. All right. If you have a question or if you remember, let me know. Okay. Here we go. So from part 1 through 8, they are pretty much always kind of working together. So they'll work all the way from 1 through 8 on their own, and they'll check with me, or if I have a TA at the time, I put in their name there. And then I let them kind of check their answers, because these should be pretty straightforward, 1 through 8. And so we kind of check all of that at the same time once they've finished part A. So now we're getting into part 2, which is inference, simulation-based inference for the regression slope. So part 9 picks up with, you should have found a positive association between the foot length and height. The question is, if there were no association between foot length and height, how likely is it that you would get a slope as large or even larger just by chance? And now we're going to apply that 3S strategy. So Jill talked to you a little bit about the 3S strategy last week. We're going to see that same strategy again. The 3S strategy, the 3 S's are statistics, simulate, and strength of evidence. So because for my class, this is coming kind of towards the end of the term, they have seen the 3S strategy quite a few times. So they can actually, relate to the strategy already. So the first S is going to be some statistic that they have obtained from the data that looks at the association between the two variables. So here we're going to just pick slope. Then I ask them, so by the time we're at this point in the quarter or the term, we have done enough tactile simulations that I can ask them how they're going to describe to me how you would carry out a tactile simulation. But I might not necessarily have them carry out the tactile simulation. But let's say if I were to, do you have suggestions for what I might use? Might I use coins, cards, dice? What am I going to use? If you were one of my students and we're like in week 9 or 10 of a 10-quarter class, what do you think my students are suggesting we use? Card sounds good. So I have 20 people in this data set, right? So maybe I use 20 cards. And Jill talked to you about this last session, that you can have their responses written on these 20 cards. So essentially you would have the heights written out on the 20 cards, and you would kind of shuffle up the heights and then pair them up randomly with these different foot length values. So essentially, you're mimicking what would have happened in the study had heights been unrelated to foot length. So if heights and foot length had nothing to do with each other, any one of these, where are we? Any one of these 20 values of foot length could go with any one of these 20 values of height. So you can just write these 74, 66, 77 on one. So 74 would go on one card, 66 would go on another card, and so on. And then you would shuffle these 20 values of heights up and then randomly pair them with different values of foot length. And that would mimic what would happen had foot length and heights been unassociated or independent of each other. All right. So that's kind of typically what my students describe the simulation process to be. And because 20 is not that massive a number, it could be reasonably carried out as a tactile simulation in class. And then we have the strength of evidence. So now we're going to say, okay, well, you've done the tactile simulation where maybe what you can do is you can generate, each student does one of these tactile simulations where they kind of pair up the heights randomly with the foot lengths, and then for this new shuffled data set, calculate what the slope might be. And then once each student has kind of calculated one possible value of what the slope might be for the shuffled data, you can throw it on Jamboard, or something like that, or maybe just make a dot plot on a blackboard or chalkboard, kind of compare how your observed slope compared to the shuffled slope values. And we'll see all of that via the applet actually in a little bit. So that would be the 3S strategy for the simulation based if you were doing the tactile simulation. So what I'd like to do is I'd like to kind of get into what the applet does for us, and we're going to go back to our applet. And so if you're not on the applet already, I'd go ahead and get back in the applet, and we're going to take a look at what the applet does for us simulation wise. Okay. And please feel free to stop me and ask questions if you have questions about what the applet is doing. So we have our observed data. So this is how it turned out for the 20 students in the class who had their height and foot length data provided. This is the regression equation for that observed data set. And now we're going to say is shuffle options, so shuffle options. And from the choose statistic, we're going to pick the slope, because that's the statistic that we are looking at to summarize this association or to quantify the association between height and foot length. And notice now that on the bottom of this graph, it says shuffle slope because it's going to record what the slope might have been had height and foot length values been shuffled. So mixing up or randomly pairing the heights with foot lengths. So I'm going to keep a number of shuffles at 1 and then shuffle the Y value. So I'm basically just shuffling the height values and pairing them up randomly with the foot length. So if I do that, you can see that the red line that you're seeing here is the original line. And then it's kind of shuffled up the heights, matched them with the foot lengths, and it's showing you what the data could have been had height and foot length been independent of each other, or there had been no association between the two. And the blue line tells you what the regression equation might have been had there been no association between height and foot length for the shuffled data that you're seeing now. You can also see that there is a data button there. So if you click on the radio button that says data, notice that the foot length values are the same as the original data set, but the height values have been shuffled. And so we can kind of go back and forth between the data and the plot button to kind of see what's happening. Now, for this blue line, which is the most recent, which is the regression line for the recently shuffled data, it tells you that the most recent shuffled slope is negative 0.21. So is negative 0.21 a more extreme slope or a less extreme slope than the 1.03? What do you think? And now you're kind of also trying to interpret what I mean by extreme. It's less extreme. Why do you say less extreme? Because it's closer to 0. That's right. So it's showing less of an association because less steep of a slope, less of a difference from 0. That's right. And we can do that. And so notice that in this plot there, it's plotted the shuffle slope. So we can do this a few times and you get different values. And the most recent is always colored blue. It's the darker, most recent one. And you can kind of click on each of them to show you what the data set, the shuffled data look like for that particular shuffled slope. And so I'm going to crank this up to, this is shuffle number 7. I'm going to go up all the way to 993 for a total of 1,000. And that's my generated null distribution for the shuffled slopes. So if I had done this shuffling and recording of the slope 1,000 times and gotten 1,000 values of slopes, this is what this picture would have looked like, this null distribution looks like. This is what they would be doing. So I'm answering Tina's question on, is this a first intro stats class or a second? So this is in my first intro stats class. And depending on, where the first intro stops, if they don't do regression there, it could be in the second or the follow-up stats class as well. Depends on how far it goes on the first one. Okay, so this is a nice picture. Why do we care? What are we doing with this picture? Help me out. So you can either put it in the chat or unmute and tell me what is the point of this distribution. Most of the shuffle data has slope closer to 0 than we saw. That's good observation. What else? How unusual. Okay. So so you're all kind of getting the point, right? So this is what the distribution of slope values could have been had there been no association between height and foot length. What actually happened in the data, in the actual data, in the observed data from our sample of 20 students, the slope was 1.03. So how unusual is it to see a slope of 1.03? And we can look at that in this applet. We're going to put in 1.03 in our box that's next to count shuffles and see, well, let's see how often something like 1.03 or something even weirder, more extreme, more out there happen. How we know if 1.03 is ridiculous or out there is if we look around and see there's even fewer things that are out there compared like that are even more out there than that. So I'm going to go ahead and say count, and none of those 1001 times did I see something more extreme than 1.03. And you can increase the number of shuffles, and maybe at some point you'll start getting something that's a little bit more in. Okay. Questions. Thank you for asking questions. So I think, yeah, so Beth answered that, but we do have, so I think Adam, you asked this question about you could do and create correlated population and then generate from there. Yes, absolutely. But I don't know that I have tried that with my intro stat students. Maybe that's something that I might try with my like the second course students, a different way of simulating. All right. All right. So let's see where we are at with our exploration. So we've done our number of shuffles, we changed them, we went up, and we are seeing how unusual. So here we are, this number here, it's telling us that 3 out of about 15,000 times did we see something as or more extreme than 1.03. So notice that under count shuffles, I've said greater than. I could use, so I have an option of greater than, less than, or beyond. So less than would give me the other direction, but greater than, I'm going to go ahead and kind of reset this. I think the number of shuffles has gotten too large for it. So I'm going to just make that 1000 for now. Yeah, it's clever that it knows if you didn't pick a statistic, it'll pick the slope for you. Okay, so if I pick the less than option, it'll choose everything below. If I pick the beyond option, it's going to pick everything in the tails from 1.03 and up and negative 1.03 and down. And this is kind of where you're helping students make that choice between what kind of alternative hypothesis did they use. Did they use one-sided, two-sided? If they used a two-sided, they should be looking at both tails. And so the beyond goes for a two-sided alternative hypothesis. All right. This is what the simulation is estimating the p-value to be. Something I kind of make a note of when we're looking at p-values is if the applet said, based on the simulation, that the p-value is 0 out of 1000, I usually tell them you should write the p-value is approximately 0, or the p-value is less than 1 in 1000 or less than 0.001. Just to kind of drive home the point that it's not impossible for the slope to be 1.03 by chance alone. It's just very unlikely. And by very unlikely, we're saying that the probability is almost close to 0 or less than 1 in 1,000, just to make sure that they don't say p-value is equal to 0. So then they can make, they have that p-value, they can state a conclusion based on that. It's a small p-value. So they would say, well, based on our data set, we have strong evidence that there is an association, there's a positive association, positive linear association between foot length and height. So, at a crime scene investigation, it would make sense to use foot length to predict what the height of the perpetrator or criminal might be. Some cool things about this activity: you don't have to talk about linear regression to get into the simulation-based inference. If you've just done correlation coefficient, you can just go with that. So if you just choose statistic to be correlation, you can get the null distribution of the shuffled correlation, and then just use the correlation coefficient, which we saw earlier, to be 0.711 in here. So, should give you exactly the same correlation coefficient that the slope had given you. Other things that you could do, you could talk about, so some other extensions would be looking at the coefficient of determination, or R square, and talking about R square as being a measure of how much of the variation in height has been explained by this linear association with foot length. And then you can use that R square to also, so you can use either correlation, you can use R square, you can use slope as part of your, as your statistic in that 3S process. And that using R square gets into a nice discussion about why this, distribution doesn't look symmetric, why it's not centered at 0, those kinds of things. So those are lots of ideas to talk about with your students, and see how in-depth their understanding of distributional properties of statistics, where that understanding is at. And finishing up here, so we have follow-up. If you want to get into multivariable thinking, you can say, okay, well, let's say this, they have found a foot length, but what else do you think explains height? Or what else do you think could be a good predictor of height? And what are some variables that you could look out for? What are some other pieces of information that you could look out for at the site of, at the crime scene, that the investigator could use? So maybe you found a handprint as well. Is someone's hand span associated with how tall they are? And you can get into multivariable thinking as well. So I'm going to go back to our, because we only have a few minutes left. I'm going to mention a couple of things before we wrap up. So what do they see after they have completed this? So where to go from that lab or exploration? They can get into multivariable thinking. They can carry out separate regressions with a few different explanatory variables and compare R square values, if that's something that's more based on the particular class level that you're looking at. They could carry out a multiple regression if they are in a Stat 2 course, or more advanced course than a Stat 1 course. After class, they again complete another concept check, where they're basically doing a same kind of thing, but a little bit more extensive. So now I'm asking them, what is the null hypothesis? What is the alternative hypothesis? In addition to asking them those usual questions, I'm asking them, how would you carry out the simulation? So, you would get 50 cards, you would write price down, and so on. Now, here is the equation of a line. Tell me how you would interpret the observed slope. Which of these, you calculate a p-value, which of these is a good conclusion based on the p-value. So trying to see if what they got out of that lab or that exploration. Key takeaways: the null hypothesis basically is simulating, or the null hypothesis is simulated via this breaking of the association between the explanatory and response in the simulation-based inference. So that's the big idea that you want to keep in mind. if you like introducing correlation and regression early on in the quarter or term or semester, you don't have to wait till the end. I do, because that's the ordering of my topics. But you can actually get to it right away, because you don't have to wait to talk about t distributions, et cetera, and probability models to talk about simulation-based inference, because you can talk about using correlation coefficient and slope, or R square, as your statistics of interest in that 3S strategy, and then use simulation to decide if that observed statistic value looks, extreme enough to provide evidence against the null hypothesis. The foot length and height context, I talked about this already, but it's great because it gets students to kind of think like investigators, and allows you to collect data on students, and students love context that they can see themselves in the data. Other possible contexts that we look at, students can brainstorm what features about a house predicts its price, and then they can collect their own data on Zillow, or what have you, go online and collect data on houses and prices in their community. So that kind of ties them to their community too. They can look at various school sizes, faculty-student ratios, tuition, and those associations. They get to look at school characteristics and median post-graduation salaries. These are actually contexts that my students have looked at. They can also look at data from published research articles, and we have a bunch of materials on our Stub website, and that is actually an active link, so you can actually go in there. So Stub is our biology related materials for intro stats and intermediate stats that you can look at. And I'm going to stop and give you a chance. I know we only have a couple of minutes, but I'm going to stop now so you can ask questions. A quick reminder again, Beth Chance is going to talk about the Monty Hall problem next week. And please note the different times. So it's 5 p.m. Eastern time instead of our usual, whatever this is, sorry, it's 11 a.m. Pacific time. I'm going to get my times mixed up. And that's our project webpage.
Thank you so much. That project webpage is where the recording will be posted later if you want to look at it later, or ask a colleague to look at it later. We have a question in the chat, Soma. Do you have students explore removing outliers and see how the correlation and the least squares line equation changes?
Yes, we do. So I didn't get to that, but yeah. So in the Stub materials, actually, there are lots of things about, like, here, the couple of lessons leading into this lesson and couple of lessons post this lesson. So some of those will look at, you have, if you have identify any observations as being outliers or unusual observations, how do you kind of gauge their impact? So you can see how the correlation changes, how the slope changes, those aspects.
Thank you. It's just about the top of the hour, but we could take another question or two if anyone has one. Comment in the chat. You can move the dots in the applet, just click on them and drag them around and see in real time the effect of changing an X value or a Y value on the line and the correlation.
That is true.
Questions, comments? Well, like Soma said, please remember even though this is the last Friday of February, there's one more session in the Fun Fridays in February series of workshops. So March 1st is close enough to February. We're going to squeeze one in next week at 3 hours later than usual. And the recording will be posted later, probably later today, certainly over the weekend, if not later today.
Oh, and
Go ahead.
Yeah, I just wanted to make sure. So on the page for the resources, there's actually also completed solutions for this lab.
Okay, thank you so much. Thank you, everyone. Hope to see you next Friday. I'll stop the recording now.